Hi, this is Muhammad Fahad Sheikh. I'm from the CSCI-E90 Cloud Computing and the Internet of Things course. And my project is a Internet of Things Raspberry Pi Microsoft Azure Cloud smart clock. As a brief overview, we are setting up the Raspberry Pi to act as a smart alarm clock, which can be configured remotely by a standalone device, an IoT device that's also hooked up to the cloud. That device can send messages to the smart alarm clock. Some of the features of the clock are the clock has this time automatically set. The remote controller can set and stop the alarm remotely. And the remote controller can also be used and kept at a distance. Thus, when the alarm does ring in the morning, the user has to get out of bed and to turn off the alarm, thus hopefully waking him up. The remote controller can also send messages to the clock as reminders for the user. And all messages to and from the clock are handled by Azure Cloud Services utilizing the Azure IoT Node SDK and the Azure IoT Hub. So taking a look at the Microsoft Azure IoT Hub, the IoT Hub is the central component that manages all communication between several IoT devices. In the Azure management area, you could set up an IoT hub. You can have several IoT hubs, and each IoT hub can have many devices connected to it. The hub then allows for bi-directional communication between itself and the devices. And the hub and the devices can send messages to each other, and each device in turn can also watch for events, such as messages being delivered to the hub and acting upon them. This is one of the main methods that devices can act on reactions or sensors from other devices. Messages will be sent to the hub, and you can track those messages down and subscribe to them. And when you see those messages coming to the hub, you can act upon them. Several policy options are also available to configure in the IoT Hub. This limits the communication, and also you can reroute some of the messages to other endpoints, which can be subscribed to. The SDKs for the Azure IoT are available in .NET, Java, Node.js, and we will be utilizing the Node.js variant for the smart alarm clock. This is the look at the Azure IoT page. Once you create the clock, you will be presented with this dashboard, and it has several options of configuring the IoT Hub with several policies you can implement so that all messages cannot be read by any device. As you can see here, one of the main key points is the endpoints and the routes options. In endpoints, they're essentially channels you can subscribe to. So you can create multiple channels, and each channel can be subscribed to by a variety of different devices. And the routing, what it does is, if messages come in and they have a specific text, they can be automatically routed by the hub itself to a specific channel, and it does not have to be pre-configured. As for the smart alarm clock project, I will be utilizing a single endpoint, and all messages to and from the alarm clock and from the remote controller app will be sent to the hub, and each individual device will just monitor the hub's incoming requests and look for key phrases, and if they see those phrases, they'll act upon them. The communication between the clock and the remote control, each device connected to the hub has a unique connection string provided by Azure Cloud when the device is initially registered. So when you initially register the device, there's a command line for it, and you can do it on the IoT Hub itself. When you send the command to register your device, a unique string comes back, which is your connection string. This string by itself can connect to the Azure Cloud, and no other credentials are needed. The hub itself also has a unique connection string, which you can obtain from the IoT website. The connection string provides a secure connection to the Azure Cloud and must be kept private, as anyone with the string can gain access. As you will shortly see in the next slide, that the string is all you need, and once you have that, you can connect to the cloud and start receiving and listening in on messages. There are several flavors of the SDK in Node. One is for the hub and the other is for devices. In both cases, the connection string is passed to the client object, which then makes a secure connection with the Azure cloud. Once the connection has been made, a simple message system can be used to listen to all communication either to the device itself or to the hub from other devices. Options are available to filter the messages by device or by group or even by hub. This is a code example from the remote controller application portion of the project. I've trimmed down a lot of the Node.js and Express code and just limited it to exactly what is needed to communicate with the IoT hub. As you can see from the top, just 2 imports were needed to get the packages for Azure IoT device HTTP and the Azure IoT device. The Azure IoT device has the message, and the client from connection string is what gets us connected to the IoT hub. The connection string here, you just replace it with the IoT hub or actually the device ID for this specific thing. So this is the remote controller app. So when I registered the remote controller IoT device, it gave me a unique string, and I would just place that here. And at the bottom here, you can see where the call is being made. So the client.open connect callback, it uses the string and creates a call and connection to the IoT hub. And once that connection is made, this callback is triggered. And in the callback, you can see that I am using socket.io, which is a Node.js package which lets the backend communicate with the front-end application. As this is the Node backend and a React.js front-end application, I needed a way to communicate between them two. So what happens here is once the connection is made, the socket is listening for certain commands from the application, from the remote controller, such as set, stop, and tweet or message. And when it gets those messages, it takes the data from the front end and then logs it to the console so you can monitor what's happening. And then what it does is uses the client object, which is the object for Azure Cloud, and just does a send event and wraps the data in a message and sends it off to Azure Cloud. And that's all there is to it. And at the bottom, at least in this example, the remote controller does not necessarily listen to stuff coming from Azure Cloud, but I did implement a simple listening right here, and all it does is it listens to any message coming from the client, and then it just logs it out in the console. And essentially this is exactly the type of functionality that is used in the clock portion of the application, which will be deployed on the Raspberry Pi. Essentially, I'm listening to messages such as stop, set, and tweet, which are received from the IoT hub, and I act upon them and trigger the various functions of the alarm clock. So how to actually run the clock? So there's 2 Node applications. One is installed on the Raspberry Pi, and the other is going to be installed on a PC or any kind of other machine, a server. The one that is installed on the server is for the remote controller application, and once it's launched and runs, that URL can be used by such Android phone or iPhone, and that will suddenly display the remote controller that will control the Raspberry Pi. And it's just 2 simple bash scripts commands, and you have to execute it on the Raspberry Pi and on the PC, and it will run the server and it'll get everything started on 2 separate IP addresses. Here's the actual running code. On the left, you can see the clock on the Raspberry Pi. It's a nice interface. It has all the features a clock should have: AM, PM, and the date, time, as well as a little symbol where it shows if the alarm is on or off. And at the bottom here, it shows the meeting at 9 a.m. That's where the messages come in. And right now, that message is set to meeting at 9 a.m. And on the right side is the main controller for the app, and this is currently running on an Android device. And it has 3 options. So if I put the input on top to, for instance, 517 and hit set, it'll send the message to Azure Cloud. The Raspberry Pi will listen to messages going to the cloud and detect the keyword set and act upon it and set the alarm for 517. Once the alarm starts ringing, I can then hit the stop button on the clock on the remote controller, which again will send a message to the Azure cloud, which will be read by the Pi and stop the alarm from ringing. Also, I can write down a message on top, like such as meeting at 9 a.m., hit the message button, and again, through the hub, it will get to the Raspberry Pi device, and the Pi will act upon it and show the meeting at 9 a.m. At the bottom. One of the tools that I use to develop it, which is available by Azure, is the Device Explorer tool. The Device Explorer tool, once you, in the configuration tab, give the IoT Hub primary key, which is available on the Azure website, you can get all the devices currently connected to the hub. And then on the other tab, the data tab, on any device you can select it and start monitoring any logs that are going to and from that device. So this is the controller device, and as you can see, I'm sending a message meeting at 9 a.m. I'm setting the alarm to set it at, and later on I'm setting a stop command. And on this end, on the third tab, is the messages to the device. And what I can do is select, for instance, the Raspberry Pi. And this was before I made the controller app. And I just made the Raspberry Pi portion, but I can use this tool to send messages and test the features of the device just by setting the messages set 502, and it'll actually give a message saying success, that the device did receive it. And here's some bigger pictures for you to see for the tool. Here's the device itself. It's just a Raspberry Pi attached to a screen. The screen is touchscreen. It helped with development, but it is not necessary for use. And my thoughts and impressions on the IoT cloud. This project was great at setting up the basics for the Azure cloud. It sets up a basic home IoT system with a central hub. Devices can connect to it, and each device can send messages and receive messages and act upon those messages, which is again the basis for any IoT ecosystem. Sending messages to the hub and subscribing to the messages events allows multiple devices to communicate using the centralized endpoint. I did not show it here, but you could actually have the remote application running on several phones by just going to that URL, and each phone can send messages to the clock and set alarms, stop alarms, and in the same sense, I can actually have multiple clocks running on several Raspberry Pi devices, and each one can receive the stop and start messages and the messages themselves. The advantages to the Azure IoT Cloud is it's very easy to set up and get going, great documentation, and Azure provides a very modern user interface compared to sites like AWS, which looks and has a great design. The single connection string makes it very easy to get started and connect multiple devices to the single hub. The disadvantages, though, the UI is very slow and not very fluid. It's not very responsive feel to it. That's just for the Azure cloud. And other disadvantages are the single connection, though easy, is a huge security risk, because if it gets out into the public, anybody can come and listen to the messages and send messages on your hub, and it could lead to unintentional access. Overall, I highly recommend the Microsoft Azure Cloud, and we'll continue working with it. Thanks for watching. Links are below to the GitHub page for both the alarm clock and the alarm clock remote individually. For more detail, you can read my paper on how to set it up, and I will be later on uploading that also as a README to each of these GitHub pages. And thank you. Bye.